In this video, we will prove the power rule. Here's the power rule. It says that the derivative of x to the power n is equal to n times x to the power n minus 1. And this is true for n going from 1, 2, 3. That means all the positive integer. So let's take a look at the power rule. By taking the derivative, we lose one power. So from power n, we lose 1 so that we end up with power n minus 1. But then in front, we have a factor n. So how are we going to prove this? To prove this, what are we going to do? To use what we call the proof by induction. Meaning, the first thing we're going to do is to show that it is true for n equals 1. Second thing is show that if true for n, then it must be true for n plus 1. Right? The logic is simple. If you have proven that it is true for n equals 1, and also that if it is true for some n, then it must be true for n plus 1. So combining the two arguments, we know that since it's true for n equals 1, it must be true for n plus 1, and that is 2. And if it is true for 2, then it must be true for 3. And if it is true for 3, it must be true for 4, etc. Right? So the first thing we're going to do is so that it's true for n equals 1. For n equals 1, d dx of x to the power 1 is just d dx of x, and that is equal to 1. But we can always write this as 1 times x to the power of 0. So this is true for n equals 1. This is precisely the expression when n equals 1. So yes, true for n equals 1. Second, suppose it is true for n. Now let's calculate the derivative for n plus 1. Now, what is it going to be? This is very simple. We're going to write this as a product. X to the power of n plus 1 is simply x to the power of n times x. And then now we're going to use the product rule. The product rule says that this will be equal to the derivative of the first term, and that is derivative of x to the power of n times x, plus the first term times the derivative of the second term, and that is the derivative of x. Now, since it is true for n, we apply the assumption for the first term. This will give us n to the power n times x to the power of minus 1 times x, plus the second term, which is x to the power of n times the derivative of x with respect to x, and that gives us 1. Right? So be careful, this 1 comes from the derivative of x with respect to x, whereas this comes from the derivative of x to the power n when we apply, because we have supposed that it is true. So therefore we can apply the rule for this first term. And now you're going to see that this is, when tidied up, this gives us what we want. And this is n plus 1 times x to the power of n. And this is the formula when we substitute n plus 1 into the power rule, right? So precisely, the derivative of x to the power of n plus 1 is simply as given by the power rule. We lose one power, so the power of x becomes n, but then we have a factor n plus 1 in front.